Hi everyone, in this video I'm just going to go over the example that we were going to do in class. This is on page 5 in your notes. It just might be helpful if you find you're struggling a little bit with the practice. So, in this problem we have a particle that's moving along a line so that its position at any time t is greater than or equal to 0 is given by this function. We have s is measured in meters and t is measured in seconds. So the first question they're asking is find the displacement of the particle during the first 2 seconds. Now remember, displacement tells us how far the particle is from where it started. So in this case, I want to know during the first 2 seconds, so its position at the end was s of 2, and then I'm going to subtract off its initial position s of 0. And that'll tell me how far it is from where it started. So let's see, s of 2 is going to be 2 squared minus 4 times 2 plus 3. So I've got 4 minus 8 is negative 4 plus 3 is a negative 1. So I have negative 1 minus s of 0 is just going to be 3, which is negative 4, and my units are meters. So that's going to tell us it's 4 meters to the left of where it started. All right, part B is asking for the average velocity of the particle during the first 4 seconds. Now, average velocity, I know is going to be that change in position over the change in time. So my average velocity is going to be s of 4 minus s of 0 over 4 minus 0. All right, so let's calculate s of 4. We have 4 squared minus 4 times 4 plus 3. So 16 minus 16 is 0 plus 3 is 0. So I have 3 minus s of 0 we know is 3 over 4. So I get 0 over 4, which is 0 meters per second. All right, now for part C, this is the instantaneous velocity, right? I'm looking at a specific point in time, so I know this is going to be the derivative of my position function. So my instantaneous velocity, we call that v of t, is going to be, if I look at my function, 2t minus 4. So at t equals 4, I'm finding v of 4, which is 2 times 4 minus 4, or 8 minus 4, which is 4, and again my units will be meters per second. Okay, my next question is asking for the acceleration of the particle. Acceleration, I know, is going to be the derivative of velocity. So now a of t is equal to, well, if I take the derivative of velocity, it's just 2. So that's a constant acceleration. So then a of 4, my acceleration is still going to be 2, and now my units are meters per second squared. All right. Now the last question is asking us to describe the motion of the particle. And it's asking at what values of t does the particle change directions. So I know I'm going to be looking at velocity here. So we're going to analyze velocity. So when velocity is greater than 0, I know my object is traveling to the right. And when velocity is less than 0, it's moving to the left. So we're going to take our velocity function, and if I look back, that was 2t minus 4, and I'm going to set it equal to 0. So now I have If I factor that out, I get this, and I know that t is equal to 2. So just like we were used to doing last chapter, we're going to set up our chart here. Now, I know it told us it's for time t is greater than or equal to 0. Obviously, it wouldn't make sense to have a negative time. So I'm going to have 0, velocity 0 at 2, and then we could keep going. So I'm going to test a positive 1. I know 1 minus 2 is going to give me a negative 1, so that value is going to be negative. For time greater than 2, that's going to be positive. So I know the particle is moving right for time between 2 and infinity seconds. And then it's moving left for all times in between 0 and 2 seconds. That means I change directions wherever I change signs, so the particle changes directions at t equals 2 seconds. So these are the types of problems we'll be expecting you to be comfortable with after video 1, and then from here we'll be moving on. All right, that's it. Thanks.